We've all used the word energy before, and we can all tell when we have it and when we don't. But what is it? Energy isn't really a thing in the traditional sense. It doesn't matter, so when you have a lot of it, you don't have more mass than before. You will sometimes hear it described as if it were matter as particles of energy, such as photons, but that is more a tool to conceptualize the concept of energy than an accurate description of what it really is. The best way to explain energy is to say that it is the ability or potential to do work. Work meaning to move matter. Your arm is made of matter, so when you raise it, you're moving matter or doing work. You need energy to do that. If I asked you to walk across the room and back without stopping, you could do that. However, if I asked you to walk across the country and back without stopping, you couldn't. You're moving the same amount of mass, but you're moving it much further this time. You're doing much more work, so it takes a lot more energy. You don't have enough energy to walk across the country. The reason a car needs its gas or battery is because they provide energy to the car. If the car runs out of gas or the battery runs out, the car quickly runs out of energy and stops moving. The more energy you have, the more work you can do, meaning you can move more mass further. You've probably noticed that sometimes it's easier to move around than others, that sometimes you just feel too tired. That happens because the amount of energy in your body is constantly changing. Whenever matter interacts, energy is transferred back and forth. When you sit in a chair, it gets warm because your body transfers energy to the chair. When you eat a piece of bread, the energy that was holding its compounds together are transferred to you. If you bump into a wall, you feel pain because more energy was transferred to your body than it was supposed to receive. Energy is involved in pretty much everything. There are a lot of different forms of energy, such as radiant energy, electrical energy, sound energy, and thermal energy. But we are going to focus on one particular form of energy called mechanical energy, because it is relatively simple to visualize and will give you the background you'll need to look into some of the other forms of energy later on. Mechanical energy is energy associated with the motion and position of objects. Just based on where an object is in the universe and how it's moving, it probably has some energy. Mechanical energy, like most of the other forms of energy, can be divided into specific types of energy called kinetic and potential energy. Kinetic energy is the energy of an object because of its state of motion. So it is the motion part of mechanical energy. It tells you how an object is moving and how much energy it has as a result of that motion. Potential energy is the energy of position. It describes the potential an object has to move because of its position in the universe. So, it is the position part of mechanical energy. An elastic that has been stretched has the potential to move, or a ball held in the air has the potential to fall. Both of these objects, the elastic and the ball, have the potential to move, to do work, just because of where they are in the universe. So, they have energy. Since mechanical energy is made up of kinetic and potential energy, the formula you would use to find mechanical energy is simply kinetic energy plus potential energy. The unit for energy is the same as the unit for work, the joule or the Newton meter. It equals distance traveled, or that you could travel, times how much force it took to get there. Since kinetic energy is the energy of motion, it depends largely on how fast an object is moving. However, it also depends on how big the object is. Think of it this way. If someone throws a tennis ball at you as hard as they can, it'll probably hurt. You may even get a bruise. However, even though it's moving very fast, it probably won't break any bones or do any serious damage. This is because it does not have a lot of mass, so it does not have that much energy. Now, imagine someone throwing a medicine ball or bowling ball at you. They wouldn't be able to throw it as fast as the tennis ball, but they both have a lot more mass. If one of those hits you, it will probably do a lot more than just leave a bruise. It'll probably knock you over. The bowling ball has a lot more energy than the tennis ball. You could also try to imagine the difference between tackling a youth football running back weighing 100 pounds and running 12 miles per hour and tackling an NFL running back weighing 220 pounds and running 18 to 20 miles an hour. The NFL running back has more mass and higher velocity, so he has more energy, meaning it will be harder to make him stop moving. Potential energy can come in a few different forms, but for mechanical potential energy, there are two main types: elastic potential energy and gravitational potential energy. Elastic potential energy is an object's potential to spring back after being strained somehow. For example, think about stretching a rubber band or compressing a string. When you do any of these things, the objects build up mechanical potential energy. If you let go and allow them to move, they will. Hunters for thousands of years have been using this concept to launch arrows using the potential energy stored in their bows. Many of your tendons and ligaments work this way as well, by pulling your body back to its resting position after it has been strained. Gravitational potential energy is an object's potential to move as a result of gravity. Basically, its potential to fall. Falling out of bed and having an airplane are very different experiences because you have a lot more gravitational potential energy when in the airplane. The amount of gravitational potential energy you have depends on your mass, the force of gravity, and how high you are. Your mass and the force of gravity together are your weight. So you could also say that gravitational potential energy depends on the weight and height of an object. The higher you are and the heavier you are, the more dangerous a fall becomes and the bigger a dent in the ground you're going to make. This is also why ants can just get up and walk away when you sweep them off a table, because they have less mass and resultantly less energy involved in their fall. When objects rise and fall, or elastics are drawn back and released, the amount of potential and kinetic energy will fluctuate. However, the total mechanical energy of the object will remain the same until it collides with something and transfers its energy. As you draw back an elastic, it builds potential energy. But like the elastic go, the elastic starts to move, meaning its kinetic energy increases. The elastic will then return to the position that it had before being stretched, meaning that its potential energy decreases. Before it was let go, its energy was mostly potential. However, when it was let go, that potential energy was converted into kinetic energy, making the elastic start to move. When you throw a baseball into the air, the same concept applies. When you first throw it, it has a small amount of gravitational potential energy, but a lot of kinetic energy. As it goes higher and higher, it slows down, meaning that its kinetic energy decreases, but since it is now higher, its potential to fall has increased, so its gravitational potential energy has increased. At the very top of the throw, the ball is not moving at all, so it has no kinetic energy, but it is at its highest point and thus has its maximum amount of potential energy. As it falls back down, its height gets lower, but its velocity increases, so its energy goes the other way, with potential decreasing and kinetic increasing. Throughout the throw, the total mechanical energy remained the same, but the amount of kinetic and potential energy making up that total shifted as the ball rose and fell. When the ball hits the ground and stops moving, its mechanical energy is gone. Where did it go? Energy that appears to be lost, as when a ball hits the ground and stops moving, is really just transferred into a new form. There are 7 forms of energy. Some examples are thermal, sound, and radiant or light energy. Energy is converted from one form to another constantly and is involved in nearly every event or occurrence in the universe. When the ball hits the ground, its mechanical energy transferred to the ground in the form of sound energy, thermal energy, and maybe even mechanical energy.